When you see food waste, what do you see? Or probably smell. What about plants or agricultural waste? Well, this group of people probably sees biofuels. My name's Valerie and I'm the Outreach Coordinator of Future Energy Systems, or FES. FES is a research program at the University of Alberta focused on studying the energy transition. Thanks so much for joining us to learn about biofuels. Biofuels are fuels made from biomass, once living material. In this series of clips, we'll meet 3 researchers who are studying biofuels in different ways. And with one of them, head to the lab. Let's meet some researchers. Meet Yu-Hao Hung, a PhD candidate who will start by explaining some of the basics of climate change and biofuels. Then he will share his work, which is looking at ways to increase the amount of bioethanol produced in a short time, as well as ways to measure cell growth so that they can determine how effective their methods are.
Have you ever had a fever? And the only thing you can do is to drink more water and have some sleep. That's uncomfortable, right? The fact is, our Earth is suffering from the terrible fever, which is caused by the greenhouse effect. I'm Yu-Hao Hong, and you can just call me Ronnie, and I got my bachelor's and master's degrees in food science at the National Taiwan Ocean University. And now, to focus on the biofuel research, I'm pursuing my PhD degree in bioresource and food engineering at the University of Alberta. So, in this video, I'm going to share my research, but before that, let me tell you a story. Greenhouse gases, like carbon dioxide, are released into the atmosphere from burning of fossil fuels and other activities. Greenhouse gas can trap heat. As the population and human activity increase, we release more greenhouse gases. For example, we need heat for cooking. We need electricity to charge our phone. We also need fuel for our transportation. Otherwise, getting to school, work, or other outside activity may be a lot harder. These activities are often using fossil fuel, releasing greenhouse gases, and are one of the reasons causing fever on Earth. So it is important for us to find an alternative fuel to reduce how much fossil fuel we use and carbon dioxide emission. So this is my research about biofuel. Biofuels are a fuel generated from biomass, such as plant, animal waste, or other agricultural materials. When biofuel is burned, it also releases carbon dioxide, like fossil fuel. However, the releasing carbon dioxide from biofuel, it can be recycled by the biomass. In other words, there's a balance between releasing and capturing. For fossil fuel, they are releasing carbon dioxide from millions of years ago, so it doesn't balance within a short period. Also, compared to fossil fuel, biofuel is a renewable and sustainable fuel. It won't run out as long as you use a biomass that keeps getting produced. One of the most popularly created biofuels is bioethanol, which is my focus. From biomass to bioethanol, there are many steps in the production process. First, the biomass is converted into small units like sugar. And then, microorganisms use those units or sugars to produce ethanol. The microorganisms are like a factory that use a process called fermentation to produce a desired product. In my project, ethanol is my desired product. And this is a so cool process. In our daily life, beer and wine are the famous product made from fermentation. Finally, in the processing, ethanol is recovered and purified. We can add this bioethanol to gasoline, with the partial replacement reducing the total carbon dioxide produced. Based on its benefit, Many researchers and industry are studying only bioethanol production. In the research group I am working with, we also want to find a way to boost the ethanol productivity and profit too. And my research is focusing on increasing the amount of bioethanol within a short time during the fermentation step. If we want to get higher amount of ethanol in the fermentation step, we need to provide more and more sugar to the microorganism. In my research, I use yeast. However, giving too much sugar to the yeast at once would slow the rate of eating and even damage the cell. To be able to study this, one of the important steps in my research will be to find an easy and effective way to monitor cells growth, which is related to ethanol production. For instance, imagine you really like steak and you are in a room surrounded by thousands of steak, and now you are expected to eat them all just in one meal. Just imagine that. You may be so overwhelmed that lose your appetite for steak before you even start. The same thing would happen to yeast if we provide too much sugar. Therefore, it is important to figure out the ideal feeding strategy. That is, how much sugar can be provided and how often it can be fed during fermentation to produce the ethanol of high quality and quickly. To be able to study this, one of the important steps in my research will be to find an easy and effective way to monitor cells growth, which is related to ethanol production. If we can monitor cells growth, it will let us know if the feeding strategies that I am testing are working. In addition, I'm going to focus on reducing the time required for fermentation, which can improve the overall efficiency of bioethanol production. I hope this research can bring an idea to stimulate bioethanol production and increase the chance for it to be adopted into the ethanol industry commercially. So to wrap it up, to lower the carbon dioxide emission and relieve fever for Earth, we need to find an alternative fuel to fulfill our human demand. And bioethanol is a promising biofuel used in transportation. Therefore, by improving the efficiency of ethanol production, we expect to acquire higher ethanol productivity and ethanol yield than traditional method. Thank you so much for watching this video. I hope you like it, and don't forget to subscribe this channel to get more information about energy. So see you next time. Bye.
Now that you've been introduced to bioethanol, it's time to head to the lab. Meet Dagem Haddis, a PhD candidate who is studying ways to make biofuels more cost-effective through the production of value-added products. What are they? Well, that means that at the same time as producing bioethanol, Dagem is looking at other products to produce. This allows them to reduce the cost of making biofuels because you're producing other things that have value. Are you ready to explore the lab?
The need for alternative energy is inevitable as the non-renewable energy like fossil fuel is finite, which means that one day it will run out. And one of the alternative energy is biofuel or bioethanol, which is made from different plant materials. With biofuel or bioethanol, we can reduce the amount of greenhouse gases that emit from different sources, like from our cars. However, the industrial process for generating bioethanol is hindered by high costs as the variety of pretreatment is necessary. So, to overcome this problem, integrated biorefinery strategies need to be designed that provides high ethanol recovery and value-added product like cellulose nanocrystals. Hello everyone, my name is Dagem Haddis and I'm a PhD student at University of Alberta. Today I'm going to share you my research on production of fermentable sugar and cellulose nanocrystals. My research has two steps. The first step is producing this fermentable sugar, and this fermentable sugar is used to make a bioethanol. And the second step is producing a novel nanostructured material called cellulose nanocrystal. I bet you are wondering what a cellulose nanocrystal are and what they are used for, right? So you need to wait and find out, okay? But before that, let me tell you this. In recent decades, human activities have increased, and with that, energy demand also increased. As you can see in this image, the demand for both renewable energy and non-renewable energy is continuing to increase. But unfortunately, as I said above, non-renewable energy sources have negative effect on the environment by releasing greenhouse gases and causing climate change, as well as other chemicals like sulfur that causes acid rain and affect the soil fertility as well as the aquatic environment, and many other impacts. In order to overcome such problems and still provide enough energy for everything we want, renewable energy plays a major role, which is where bioethanol comes in. So, what's a bioethanol? Bioethanol is a renewable fuel made from plant matter and produced by a sugar fermentation process. A fermentation process is a process of converting carbohydrate to alcohol or organic acid using a microorganism. So to produce bioethanol, there are three basic steps. The first step is the pretreatment step, where the cellulose opened up to help it turn into glucose. And the second step is the enzyme hydrolysis, where the cellulose is turned into glucose or sugar by the help of enzymes. An enzyme is a biological catalyst which is used to facilitate or help a biochemical reaction. And the third step and the backbone step is the fermentation step, where the glucose is turned into ethanol by the help of the yeast. I think you know what the yeast is, right? The yeast is the microorganism and that we used to make a bread, right? But however, because of the many steps and high pretreatment costs, producing this bioethanol at industrial level doesn't make sense from the financial point of view. So to overcome this many problems, we can produce multiple products, which is what I'm looking at. As you can see, during the second steps, enzyme hydrolysis, two products are made. One is the hydrolysate, which is the fermentable sugar that turned into bioethanol, and the second is the solid fraction. So this solid fraction can be turned into our cellulose nanocrystal. Remember those? Cellulose nanocrystal are a nanostructured biomaterial. This means it is made of a very, very small cellulose crystal that are extracted from wood, algae, or bacteria. And these cellulose nanocrystals have a promising application in biomedical application like in tissue engineering, drug delivery, and it also used to make food packaging material, and it is to make for cosmetic products in order to increase the viscosity, makes it harder to pour, and strength of the material. Now, I want to welcome you to our lab, and this is my workplace, and today I'm going to show you how to make a fermentable sugar, and this fermentable sugar is used to produce bioethanol and a novel nanostructured material called cellulose nanocrystal. I hope you know what's a cellulose nanocrystal, right? So, let's make it! So, to make cellulose nanocrystal and fermentable sugar, we need the following materials and chemicals. The popular wood chips that we received have already been treated with steam called steam explosion pretreatment and purified, which remove the parts we don't want, like lignin, and opens up the structure in the wood so that the cellulose can be accessed by the enzymes. Now we are going to start the second step, enzymatic hydrolysis, where we turn the cellulose into glucose. Using the scale, measure out 6 grams of pretreated popular wood chips. Then, using a graduated cylinder, add 75 ml of 0.05 molar of sodium citrate buffer. And wood chips into 500 ml flask and put a rubber stopper on flask. Then cover the stopper with a paraffin and aluminum foil to avoid loss of glucose by evaporation during enzyme hydrolysis. Put the flask in the water bath. And using a thermometer, monitor the temperature of the water and bring the flask to 50 degrees Celsius. The flask should be kept at this temperature for 1 hour and then remove the rubber stopper and add cellulase enzyme. The enzyme breaks down the cellulose and turn into glucose, and this should be done using 100 to 1000 microliter pipette. So the flasks should be kept at a constant 50 degrees Celsius in the water bath because the enzyme needs a warm environment to turn the cellulose into glucose. So after 24 hours, we separate the fermentable sugar and the solid fraction. So the fermentable sugar is going to a glucose analysis, which means that it's going to determine the amount of glucose is produced during the enzyme hydrolysis. And the solid fraction is dried and going to acid hydrolysis for the production of cellulose nanocrystal. For the acid hydrolysis of cellulose nanocrystal, it is where the solid fraction is converted into a very small cellulose. We prepare 64% with by weight sulfuric acid using a graduate cylinder. Add 8% solid consistency of sulfuric acid to 250 ml flask. Then flasks should be kept at a constant 45 degrees Celsius in the water bath. We use a thermometer to monitor the temperature. Then the dry solid fraction is placed into 250 ml flask and the acid hydrolysis happens for 2 hours. After acid hydrolysis, we separate the acid and the cellulose nanocrystal and purify to get pure cellulose nanocrystal. So to purify, first what we do is we neutralize the diluted acid suspension using sodium hydroxide to bring the pH into 7. And after that, we are going to dialyze against water in order to remove the salt that are produced during neutralization process. And then we centrifuge 2 times at 8000 G for 10 minutes. And then after that, we use freeze dryer in order to remove the moisture or the water from the suspensions, and we get a dried cellulose nanocrystal. Okay, to wrap up my work, now we have the cellulose nanocrystals, which can be used for many different purposes, and we have the sugar that will be used to create bioethanol. So if we can't find ways to make bioethanol production, it makes more sense financially, then we can play an important role in making renewable alternative energy. Thank you very much for watching my video. I hope you liked the video and you get information. And finally, I would like to thank my supervisor, Dr. David Bressler, for his guidance, advice, encouragement throughout the research work and useful suggestions and comments. And also, I would like to express my sincere appreciation to Dr. Che, Dr. Asomania, and Jungi for supporting me to carry out this research. And finally, I would like to thank all my lab mates and the funding agencies, the Future Energy Systems, Natural Science and Engineering Research Council of Canada, Alberta Pacific Forest Industry, and Innotech Alberta. Without the support of the funding agencies and my professor, this work would not have been possible. So, once again, thank you very much for your support.
We've got time to meet one more researcher. This is Megan Lim, an undergraduate student studying biojet, which is a special kind of biofuel used for flying. She is going to share many of the reasons that more biojet is needed and the potential challenges for producing it.
Hi there, my name is Megan and I'm a student studying conservation biology as well as environmental economics and policy. I've been living in Edmonton for the last 4 years, but I'm currently on exchange in New Zealand, finishing off my degree. As part of the Alberta Biojet Initiative, I've been working with lead researcher Marty Lukert and his team to study biojet. So today, I'm going to be introducing you to biojet, what it is, why we want to make it, and why not much of it is currently being made. The team I'm working with is an environmental economics group that studies biofuels at the University of Alberta. Biofuels are liquid fuels that are made from living plant matter called feedstock. While almost any biological material can be used as feedstock, common feedstocks include agricultural crops like soybean oil or sugarcane, leftover plant material like corn leaves and stalks, and waste oils like used French fry oil. Biofuels are designed to replace fossil fuels such as gasoline and diesel, but my research has focused on a special type of biofuel that is made to power airplanes. This type of biofuel is known as biojet. Unlike biofuels like ethanol and biodiesel, which have been used to power cars for well over 50 years, biojet was only invented around 20 years ago. This is because jet fuels must be made to withstand the extreme conditions airplanes fly through, and it's harder to make a biofuel that can do this. But why did we want to start making plant-based plane fuel anyway? Over the past year, I attempted to answer this question by reading over 200 publications that discussed biojet, writing down the reasons they listed, and ranking those reasons based on the number of times they were mentioned in the literature. Ultimately, I discovered that there are over 20 of these opportunities for biojet production, but here are the top 3. The number 1 opportunity is the increasing demand for jet fuel. This demand likely results from recent increases in wealth in developing countries, which mean that more of their citizens are flying more often. More demand for jet fuel means a greater opportunity for biojet producers to sell their product. But from an environmental perspective, this increase in air traffic also means an increase in greenhouse gas emissions, which are released when jet fuel is burned in an airplane's engine. These greenhouse gases contribute to global warming, which has negative impacts on the environment and society. But unlike traditional fossil jet fuel, which is made from crude oil, biojet is made from plants that absorb greenhouse gases as they grow. This means that the emissions released by a biojet-powered airplane are balanced out, or offset, by the growth of the biojet's feedstock. In this way, the production and use of biojet can result in far fewer emissions than the production and use of fossil jet fuel. Ultimately, this means that if airplanes are powered by biojet, more flights don't necessarily mean more emissions. The second reason is that biojet is currently the most feasible replacement for jet fuel. While it may also be possible to power planes on electricity or hydrogen fuel, these options pose many technological challenges and would require entirely new, expensive aircraft and infrastructure. On the other hand, biojet is convenient because it can be used in existing aircraft. The third opportunity is supportive government policy. This includes carbon pricing mechanisms like the European Union's emissions trading system. Policies like this encourage biojet use by requiring carbon emitters to pay for the greenhouse gases they create. By flying with biojet, aircraft operators pay less money to the government because they've reduced their greenhouse gas emissions. There are also policies called blending mandates, which require a certain proportion of all fuel sold to be biofuel. One well-known blending mandate is the United States Renewable Fuel Standard. In Canada, you might see the impacts of similar policies when you fill up your car with gasoline that contains 10% ethanol. But even though the vast majority of these blending mandates only require a certain proportion of ethanol or biodiesel, not biojet, many authors think that they may still benefit biojet producers, since other types of biofuel are often made alongside biojet, and since biojet may still receive credits or count towards the proportions set in the blending mandates. But despite these important opportunities, biojet currently accounts for less than 1% of the jet fuel being consumed every year. There are hardly any commercial biojet producers, and many companies either started producing biojet, then switched to other, more profitable products, or just haven't committed to building a full-size biojet plant in the first place. So why hasn't biojet taken off? This was the second question I was hoping to address. So as I was reading all of those publications, I was also recording the reasons for biojet's lack of success. I found that biojet producers face over 40 different challenges, and here are the top 3. As I'm sure you might have guessed, the biggest of those challenges is cost. Right now, it costs around 2 to 4 times more to produce biojet than it does to produce fossil jet fuel. This makes it really difficult for biojet producers to sell their premium-priced product. The biggest contributor to this cost is often the cost of the feedstock. This is because in many cases, feedstocks like crop oils are already more expensive than fossil jet fuel. Another important cost is called the capital investment cost. This includes the price of the equipment needed to make the biojet, which can be very expensive since some production methods rely on extremely high temperature and high pressure equipment. The second biggest challenge to producers is feedstock availability, since most biofuels are made from crops and there is a limited amount of land and water to grow them on. For example, one author estimates that 12% of the Earth's cropland would need to be dedicated to feedstock production in order to satisfy the global demand for jet fuel. In addition, many other industries also require feedstock, such as the ethanol and biodiesel industries. Because these fuels are more profitable than biojet, their producers often use the majority of the feedstock, leaving very little feedstock for biojet. A third important challenge facing biojet producers is sustainability, since producers must make sure that they don't harm the environment or the people living in it while making biojet. For example, research shows that some types of biojet can actually create more greenhouse gas emissions than fossil jet fuel if forested areas must be cleared to grow its feedstock. In addition, using land to grow feedstock can reduce the amount of land available to grow food for communities. Even though the biojet industry faces significant challenges, there are dozens of multi-stakeholder groups working to find solutions. With a little luck and a lot of research, biojet may someday be used in every flight around the world. Thank you so much for joining me today. I hope you enjoyed learning about biojet. I'd also like to give a special thanks to our sponsors who have supported the work we do through the Alberta Biojet Initiative. For more information on this project, you can contact Principal Investigator Marty Lukert at martylukert@ualberta.ca. He's a professor in the Department of Resource Economics and Environmental Sociology in the Faculty of Agricultural, Life, and Environmental Sciences at the University of Alberta. You can also check out more future energy systems research on the website.
So the next time you see some food waste or plants, are you going to think about it the same way? Thanks so much for joining us to learn about biofuels today. Make sure to subscribe to Future Energy Systems YouTube channel so you don't miss any of our exciting content, and check out the links below. There's so much to learn as we explore our energy future.